Welcome, humans, to the Neuron Podcast. I'm Corey Knowles, joined as always by the one and only Grant Harvey.
Hello. Today, we are unpacking Nemotron, NVIDIA's open weights model family built for everything from laptops to data centers. We'll get concrete, what the average person can do, what power users can build, how businesses should decide between local versus cloud, and how to pick between Nano, Super, and Ultra.
And for this, we're joined today by Kari Briski, VP of Generative AI for Enterprise at NVIDIA. Kari, welcome to the Neuron.
Hello, thank you for having me. Happy to be here.
That's great. We're sure glad to have you and appreciate you taking time out of what I'm sure is a wild schedule to accommodate us.
Anytime. I love it. I love little breaks. It's fun.
So, Kari, let's start with just like a very simple overview. So, what is NVIDIA Nemotron in simple terms, and why should engineers care?
NVIDIA Nemotron is a collection of not just foundation models, but it's also all of the data sets that we put out into the open source. It's recipes, and it's also the training framework, algorithms, and research. So it's just this all the work that you need in order to build a foundation model. And so it's not just the models, it's everything around it. It's all the rest. It's not just the model, but it's the ingredients in the recipe too.
That's awesome.
It is, and that's one of the things that's really impressed me, and I'd like to chat just a little bit about NVIDIA's open weight strategy. You've got more than 500 published models, tons of training data sets, and much more, and I'd argue it's, if not among the most, maybe the most transparent approach in the AI space today. Can you tell me a little bit about that strategy and why it was the right move for NVIDIA?
Yeah, I think, well, it's the right move for us because we are a developer platform. We are an AI developer platform. And the more that you put out the ingredients, it attracts even more developers. And the more developers that you attract, the more feedback that you get on your product and what you're putting out. And so it was the right move for us because we believe that everyone should be able to do their life's work and make specialized AI. And in order to do that, you need to have all the ingredients.
That's right. I even joked with Grant. I said even the Groot data and model are out there.
Yeah, yeah. If you could make a robot, you have the technology.
Yeah, it's like our three family of models, right? You have Nemotron, you have Cosmos, and you have Groot. Those are kind of our foundation model families.
Yeah. Wait. Cosmos is that the world model one?
World foundation model, that's right. Yeah,
Yeah, that's right.
understanding the
Yeah.
physical world. Yeah.
That's
Nice.
awesome. So like what sets Nemotron apart from like obviously Cosmos and Group, but then other language models in its class, like in terms of architecture, training approach, or optimizations?
Yeah, I think they're very different. So Nemotron is really kind of the brains, the understanding, the reasoning. It started out as a text-based model, but now it also understands images and the Nano does, and then also some video coming soon, and we'll get to vision later later down the line. But what sets it apart is that again, the transparency. And also the reason why we build it. I mean, we also build it for ourselves to develop our next gen architectures for like systems at scale. And so we also are building it for ourselves. So we have to understand how to build it. So we understand how the systems work. And then when we put it out into the open, I mentioned how we also released the data sets. When we started releasing the data sets, we had so many even enterprises come out and say, hey, that's fantastic. Can you help me build a model too? Even though we put
Oh,
the ingredients out, we're like, hey, we still want to kind of pick your brain and understand like how to use those data sets together. So it really sets it apart in that, again, it's trust through transparency.
That's really awesome, and I think such a refreshing approach, to be honest.
yeah.
Yeah, you said open weights earlier, and I think that it's really open source, right? 'Cause I think
Oh,
people started to say open weights because
You're
people
right.
picked apart the fact that things weren't open source. Yeah.
you are so
This is an
right. I'm so used
actually
to
open source model. Yeah.
we run into
That's
that so
amazing.
often where we got a cop saying open source. This is open weights, but in this case, it's really open source.
That's right. That's right.
Yeah.
Thank
That's
you. I
so awesome.
appreciate that.
Yeah.
What uh what can a highly technical person do with the Nemotron suite that's really impressive?
Yeah, well, I think the sky's the limit. We use it ourselves internally. We have things like deep researchers. You have your own deep researchers. If you've ever gone out to Google or Perplexity, and you can imagine that we have data that we do not want to upload into an API internally, and so we have our own deep researchers. We actually put out that blueprint for others to build their own deep researchers locally and for themselves. You can specialize them. We have a lot of customers who are specializing for their domain, so they're able to take their proprietary data, their IP, their personal data, and be able to specialize it for their use case in their domain, because nobody knows your domain better than you, and you do not want to give away your intelligence, right? So I think that so that's things you can do with the model. I think what's interesting with some of our recipes is that we put out the recipes, and some people have taken our models and distilled them on their own. And when I say distillation, that means taking a larger model and quantizing it, or reducing the precision of the weights so it's smaller and faster. So we've seen a lot of people take it and pick up our algorithms to do neural architecture search, to kind of even change the architecture of the model. So if you're a real techie, you can get into the weeds and really do your own thing, like really change the guts of the model with the tools that we've given you.
Okay, so let's talk about a tool that's completely transformed how I personally work. That's Wispr Flow. Imagine being able to write full articles, emails, even take complex notes just by talking. That's what Wispr Flow lets me do. It's hands-free writing that's smart, accurate, and ridiculously fast. For me, it solved a decade-long problem. I used to cover baseball as a beat reporter and had to file my story deep in the middle of the night. I always wanted a quality dictation tool that would let me get started on the way home. I wanted to be able to just talk my ideas into a doc. I tried several tools, they all came up short. But with Wispr Flow, I can dictate an entire piece, have it cleaned up, and file all while I'm on the go. No more waiting to get back home, fire up a laptop in the middle of the night to rush something out. I was able to take time that I already had and use it. But it's not just about accessibility, it's about productivity. You'll save hours, get your thoughts down instantly, and stay in flow without breaking a note. So, whether you're a writer, a founder, or just someone who needs to capture ideas quickly and accurately on the go, Wispr Flow makes it effortless. Seriously, you're going to want to check this one out. You'll wonder how you ever worked without it. It's available on Mac, Windows, and iPhone. Visit whisperflow.ai/neuron today and get started for free. That's whisperflow.ai/neuron. Tell them the Neuron sent you.
And now, obviously, you've told us that Nemotron is more than just models. It's the data set, it's research papers, algorithms, libraries, and more. Could you tell us more about everything that is available to people?
Yeah, I think what's interesting about the data sets is that, well, there's two things. We release the data sets that we've either created or acquired as much as we can. Sometimes we have distribution limitations, but then we try and recreate or do some sort of synthetic derivative that's differential enough to be able to release it. So what we've learned from the data set that we've acquired or paid for. And so we're actually kind of paying for these data sets and then also giving them back out to the community. The other thing is that the thing about reasoning and reinforcement learning is that you're not necessarily limited by data. You need data, but you can now do synthetic data generation, and you can create synthetic environments. And so if you think of an environment like a gym, where the more you exercise your model, the better it gets, and you give it different variations. So when it sees a problem in the real world, then it can know, so, hey, this is similar to something I've done before, and I can go solve this problem. So if you think of all of the synthetic data, because that you're just compute limited at that point. So when we have just GPUs that are doing synthetic data generation, and then we package that up and put that out. And so that's a lot of compute savings for developers in the community, because now we're not only giving away synthetic data generation, we're also giving out these gym environments. We're also giving out algorithms for the reinforcement learning. And the research is another example. So we published a paper earlier this year on it's called a hybrid transformer. So it was both a Mamba and a transformer put together, which is really efficient because it reduces some of the attention memory size of the attention layers. And so you're able to reduce the size of the model, have a highly efficient model for inference. And so that research paper actually was picked up by the Quen model. And so the latest Quen model actually released a hybrid Mamba transformer architecture. So these are the types of things that we put out into the open for kind of anyone to pick up. And but by the way, we're not just the only one putting out into the open. We love picking up and reading papers and taking the best of the open source too, and putting it back into Nemotron as well. That's the
That's
virtual
so
cycle
cool.
or the open source. Yeah.
That's really awesome. Why would a business want to use a model like Nemotron over versus AI over the cloud, for example?
Yeah, well, I kind of alluded to it a little bit earlier when I said that you don't want to give away your intelligence. So you have your own domain expertise, and you have your own private IP. You have your own specialty. I think current AI is really great. I mean, it's really great, and it's not. There's no. I'm not saying it should go away because there's room for everybody. Because when you are doing an AI application, it's systems of models. I actually kind of joked about it with a couple of our team. We were joking the other day because it's like a new object-oriented programming. You're sending agents out to do stuff and come back and return an answer. It's just like these objects to go do something. But so there's room for all types of size and models, but really enterprises want to specialize. And I think when people are talking about how enterprises really haven't adopted AI fully yet, it's because AI has been very general. And enterprises in vertical industries are highly specialized. If you think about in healthcare, in automated driving, in finance, in chip design, in you name an industry, you need to be able to take it that last mile. And so I think we're finally providing the tools. I mean, 5 years ago, stuff was really hard, right? But now we're getting to the point where you can reproduce. We have the tools. It's getting easier to train. It's cheaper to run inference, and so now enterprises can take their data and they can apply it to these models and take it the last mile that you need for specialization. And that's what's really interesting.
That's awesome. And also that reminds me too, NVIDIA put out a paper, I want to say it was like a couple months ago, about how the future is basically small models. And that kind of opened my eyes to like exactly what you're talking about. I was like, oh, okay, I get this now. Yes, there will be the giant labs like OpenAI and Anthropic and Google trying to make like the giant omni models. But also I think like people were kind of thinking like in the future there's no need to create specialized models. And I think we're at the point where it's like, no, there still is.
Yeah.
No, there's definitely a need for specialized models. I think we've been saying it for a couple of years. I just think it's the journey of understanding generative AI because it's just a completely different way of programming, right? It's a
Yeah.
completely different way of software engineering, the way that applications are going to be built in the future. And so just as you've had to change out your build systems and your test-driven development and your QA, like this is just having to redefine how you build software. And I think it's just a journey, and it's another transformation journey that enterprises are going to have to make. And that was a really great paper about small models. Uh, it's one view. I think there's also it's many models, and I think
Yeah.
that's why you kind of introduced us, and we have many size models of Nemotron because you do need larger models to inform and train the smaller models. And so you
Right.
do, and larger models are a little bit more robust, and they can kind of generalize a little bit more, even in a domain, and they have a bigger capacity to learn a new domain. So I think that there's room for all kinds of models.
Yeah, that makes perfect sense.
So how does someone, say an individual, use Nemotron? What are the, minimum hardware specs you could run one of the smaller versions or any of them on for that matter, whatever you've got handy?
Yeah, so there was a little bit of thought that went into it. It seems kind of natural that we did a small, medium, large, but there there was a little bit more thought that went into it. For our Nano, we really wanted it to fit into smaller GPU formats, right? So that anyone that's either renting what I'd say an older hardware architecture on the cloud or running on a laptop that has a GPU in it, we want to be able to run that with enough memory and at with the efficiency that you need and still have a really great reasoning model. And so that was the Nano. And so if it's a 9 billion parameter model at floating point 16, you really only need like an 18 gig memory requirement, right? So and then again, you can use our tools to quantize it down even further and make it even smaller and more efficient. Um, yeah, so that's kind of what we did for the Nano. For the Super, we were thinking we wanted to keep it within a single Hopper GPU, data center
Yeah.
GPU. And you can easily do that. You can run it in an FP8, and that's easy. For Ultra, we actually had this debate with our engineering team because a lot of these, again, a lot of the really great large models are larger than a node. And if let me just explain what a node is if you don't know, it's 8 GPUs in a box,
Yeah.
right?
Okay.
So most of these really large models are multi-node. So you have to take up more than 8 GPUs just to run one model.
Wow.
And so we actually kept the Ultra within a box. So it does take 8 GPUs to run inference on or train or just have it within the system. But we did that very specifically. Now I can't say in the future that we'll stick to those rules for Ultra. We might expand, but
Cool.
that was our thinking between Nano, Super, and Ultra.
That's good thinking. You wind up probably not wasting a lot of GPU space that I imagine you would otherwise if you're at, needing just over one or a little more than one.
Yeah, we did a survey on what were most of the enterprises using, what are their cloud instances, like what's available to them, and a lot of people were using Ampere A10s, right, or
Mm.
A10Gs or A100s, and so we really wanted to do that. And then of course we work with our GeForce team and understanding like what GPUs are going into laptops and what do we need to do to make sure that we have a really great, efficient, small model.
That's awesome.
Awesome. Yeah, I like that you're even considering people at that level because, like, Corey and I, we would love to be able to run these models on our
We do.
PCs, and
Yeah.
it's just so cool that you're able to do that. Like, yes, you can go to the frontier intelligence, but you can also run it locally. It's so awesome.
Yeah, and we do have I think we announced a little thing called Spark, which is a little development station. So Nano is great for that too.
That's
That's
awesome.
It's going to
Yeah,
awesome.
be great.
Spark looks neat.
Yeah.
It's so cute. It's so cute.
It is.
Yeah. I remember seeing the footage of it when it was like, uh, was that the video that Jensen announced where he like takes it out of the oven and he pulls it out, or was that a different
No, I
computer?
think that was a different one. I think that was like our data center rack, right? During COVID, right? Is that what you're talking about?
Yes,
You pulled out
yes,
your
those videos are great. We'll include the link to that in
served it up.
this.
Yeah.
You know how AI coding agents feel fast until you're stuck fixing their code and realize it would have been quicker to just do it yourself? Warp changes that. It's an agentic development environment, a new kind of tool that makes working with coding agents effortless. Warp connects to your code base, understands your context, and uses the best models from GPT-5 to Claude Sonnet 4.5 to generate production ready code from the jump. And when you do need to step in, Warp's built in code review and editing tools make it seamless. You can see diffs, reprompt, or make quick changes right alongside the agent. No tool switching, no wasted time. That's why over 700,000 engineers from companies like Netflix, Ramp, and Amazon are already using Warp to save hours each week. So if you're ready to go from prompt to production faster, check it out at warp.dev.
So the trend with Nemotron, as well as other open source models and open weight models of late, seems to be increasingly better performance out of the same or even smaller model sizes, like you're talking about. You might have alluded to this a little bit, but what exactly is involved in making that happen?
Yeah, so I mentioned this idea of distillation, these algorithms to distill models. And by the way, there's lots of different ways to distill models.
Oh,
There's always kind of new algorithms, but you do need the larger model to teach the smaller model. You can also take a larger model, and I mentioned to do neural architecture search. And so it's like pulling apart the Legos and kind of figuring out which pieces really matter to the design, and then putting it back together and using 30% less pieces. And so that's basically what you do when you do a neural architecture search. And so you distill it down to a smaller model, but then you retrain it back to the same accuracy. So there is a bit of like retraining back into it. And so the thing is, there's really great success with small models or these SLMs. You do give up a little bit, though, just a little bit, when I mentioned earlier, like a little bit of robustness, a little bit of capacity to learn. But they are great for specializing for particular tasks. So again, when I'm talking about systems of models, if you have a model that just needs to do a routing, so someone asks a question and I need to route to whatever the best tool is or whatever the best model that is to answer this question, you don't have to understand the world, right? You just
Yeah,
kind of have to understand your environment and what its tasks are, and you can be a really great router, but with some reasoning behind this, you're making great decisions based on that routing instead of a rules based routing. So yeah, SLMs have had that purpose, but you do need that larger model to distill down into it.
that's really, really interesting. And one of the things that's impressed me a lot is like I run 9B and yes, there are some minor sacrifices. It's really not as much as you would think compared to a 600 trillion or 600 billion parameter model, excuse me, a 600 billion parameter model. And
600
I
trillion.
was like 600 trillion. Where?
yeah, 600
I'm going.
trillion? Who's rocking
Where are you
that?
running
Yeah.
that?
Take me there.
But it's amazing to me that the difference isn't massive, at least in the tasks I'm doing with it specifically.
Exactly.
So, how do you make sure that smaller and faster doesn't mean less accurate? Is that second phase of retraining you were talking about?
Yeah, it's a lot of the post training. It's a lot of this reinforcement learning. Again, for when you do reinforcement learning, you take a question or a query, and then what we do is we synthetically generate at least 16 different variations of how you might ask the same question. And for each
Mm,
of those variations, you run that through a gym. And so this gym is a bunch of different environments. And so you might have a math gym of, if it's a math question, how might I answer that? What's the algorithm I might do? If it's a tool calling gym, what tools do I need? How would I think about this, and how would I go get right? You can imagine there's all kinds of different environments. And if you really kind of look out in the community, it's really great because all these gym environments are starting to pop up in the community. But
yeah.
so you do this post training just to give it this breadth of knowledge. We also have, for lack of a better benchmark, but there's these benchmarks out in the community. So you want to make sure that you're at least meeting that minimum benchmark without overfitting to that. So you at least want to check yourself. How am I doing on you know some math questions? How am I doing on coding? How am I doing on instruction following? So you
Mhm.
just want to make sure that you're hitting those before you even release the smaller model.
That
Right.
makes sense.
You mentioned the RL environments. Yeah, this is something that we've learned about recently. So, is it technically like a data set, or like actual like I've heard people spin up like a fake Salesforce for people to use, or like could you kind of explain that because it's really interesting?
Yeah, exactly. It's more than a data set. So that's why we call it a gym, because you're kind of working it out. And if you really think about it, it's like a little agentic system on the side that you're kind of running the model through, and you're exposing it to tools and saying, here's these things in front of you, go figure it out. I've asked
Mm,
you a question, you've put tools in front of you, go figure it out. And so you're right, you're absolutely right. People are spinning up ISV or software vendor interfaces to be able to say, hey, here's where this button is, here's what this function is. How would you do this invoice? How would you, right? And so it's very interesting. I think the space is going to get even more interesting.
That's awesome.
yeah, I love that. So you mentioned the three tiers, right? There's Nano, Super, and Ultra, and I liked how you explained like the thought process behind like which one goes where. Um, I guess like we kind of already know like what the North Star was that governed those splits was like the actual GPU that you would run it on. But what would you think is like what job should each tier own so teams don't just default to the biggest one? Like if you're getting
Uh,
in the weeds, maybe it's
yeah.
different for
No,
everyone.
yeah, no, I think it's my answer, and you're not going to like it. It depends, because it really does depend on the use case, um, your compute that you have, your latency requirements, right? So it's all about throughput, latency, and accuracy. And so when
Okay.
you triangulate between those, you kind of find the right model size for you and your task. Um, and so we have found that the sweet spot has been the super, because it fits in a single data, for at least for enterprises, it fits in a single data center GPU, because
Mhm.
enterprises want all the accuracy they can get in an itty bitty compute footprint,
So
right?
they
And
can run like as many as possible, right? Yeah.
right,
Yeah.
right.
Yeah.
And save on cost, right? So they want the most accuracy that they can, and the lowest latency on the smallest compute footprint. And that's honestly what we've been trying to deliver with all these efficiencies that we've been doing. And then the super kind of gives that more accurate than a nano, not quite as accurate as the ultra. Actually, our latest super revision just surpassed our ultra. So we've got our roadmap going. There's always innovations happening, but
That's
the
awesome.
Ultra does have we in safety and robustness tests and capacity to learn. So a lot of, like, I've talked to healthcare customers who definitely prefer the larger model because of its capacity to learn on their domain and be more robust for a given task. So I hate to say it, but it depends.
That's a
That's
totally
that was
fair
a good
answer,
answer.
and
Yeah.
kind of figured that would be the case, but it's really interesting the way you've explained it. When When should teams recognize that it's time to lean into one of the bigger models versus Nano? Like, what kind of signs are they looking for when that happens?
Normally, it's they're going for more accuracy or they've acquired more data and what we call the data flywheel. So the second you put a model out, and actually sometimes it goes in reverse. So you put a more accurate model out, the bigger model, and then once you get your data, then you start to be able to fine tune and then put the smaller model out. So it's almost sometimes goes in reverse. Um, but for people that are just starting out with the Nano and want to go larger, it's really about understanding your use case, understanding how to evaluate it. Most businesses actually kind of get stuck in this evaluation phase. It's really hard. When you start a proof of concept, you have to really narrow down the scope. It's just like any other problem. Like, how will you test it? How will you verify it? And so once you get data, once you have your evaluation metrics and your criteria and your use case, then you can start to expand your use cases and expand your accuracy and start to grow your model needs, especially your specialization needs. We see a lot of customers, if you don't mind me to kind of digress for a second,
No,
Sure.
um, it's kind of like these eras since the big bang of ChatGPT and in 2022, right? Enterprises were like, oh, what is generative AI? What do I do with it? Like, how do I use it? Like, I need something similar to that. And they're like, oh, well, I actually don't have the resources to train my own model, so I'm just going to use the managed APIs. And then
Yeah.
everyone kind of went on that proof of concept. And then in 2023 was all about that. And 2024 was about, if you've heard of RAG, retrieval
yeah.
augmented generation. They're like, oh, and they're like, oh, models hallucinate. Well, now we need RAG. RAG's my silver bullet. Like, all I need is RAG. And so they started testing with RAG, and they realized that it's just you kind of can only do so much with it. And and then they're like, "Oh, you know what? I might need to customize my model." So they came back to the conversations that we had in the beginning of 2023, where we're saying, "We really need to specialize." And like, "No, that's too much." So this is what I was talking about earlier, is this journey of understanding. And 2025 has, past RAG, 2025 has been all about agents. And because if when you were started to do RAG, you're like, "Well, I really need this to be to route to the right systems. I need it to be able to reason about what data I go pull. It just really needs to be smarter." And then RAG became a tool of agents. Instead of everything being about RAG, it's now RAG is just like a small tool that an agent can call to,
It
right? So that's kind of been the journey.
That's so
I have a
interesting.
I have a question kind of related to that, which is like when you work with like these companies, do they hire are they hiring ML engineers to do this stuff for them, or are they trying to learn it on their own? I think that's kind of interesting.
I think a little bit of both. A lot of the large enterprises are starting their own center of excellence, so their own internal platforms. A lot of it is sort of wrappers around, managed APIs, and then a little bit of open source models. Again, doing smaller tasks, and obviously Llama was a big success last year. So a lot of enterprises started with Llama or Mistral models. I've seen it in production too, and so now they're getting to the I need specialization. And we need specialization. Guess what? You need open data,
Wow.
because we need to know how the models can form, what it was trained on, why it was trained on that. You can't put this into critical applications unless you can truly trust what it's been built on and kind of open up and see inside.
That's right.
Right. So where do you feel like the Nemotron family really shines? Like where does it and then I guess the flip side of that is where does it have room to grow in your opinion?
Yeah, I think it really shines in our efficiency. I'm really proud of the hardware architecture that we've done. Again, of course, we build it for ourselves. We want to make sure we build the most efficient systems, and it's this virtuous cycle. And think it really shines on the reasoning, right? We've had really great reasoning data that we've put out. We've even helped translate it to some other languages, and so I'm really proud of the team doing that. Room to grow, I think. If I had to be really critical on on my own product, I think that right now we're working on two things. One is long, multitask, complex steps. So the
Yeah.
more tools and steps that you have to take, you can kind of get lost along the way.
Mhm.
And so you want to now we're doing more data collection for those types of scenarios. So really complex tool calling is something that we want to do better on. And then maybe this is a little bit visionary, but you know, um, we have a really great speech team, world-class speech team. We actually have, talking about open models, we've got really great speech models that top leaderboards and are open too. They're called Riva and the canary and parakeet models. We're going to
Uh-huh.
start to pull them under the Nemotron umbrella and maybe start some more Omni models. So I'm kind of, I'm excited about that.
We did a call
That's
with
awesome.
someone talking about Parakeet just a couple days ago and how they use it for podcast transcripting and things like
That's
that, and
amazing.
how
I
great it
love
is.
that.
Yeah.
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 Yeah. Again, it's like these little known secrets. People talk about Wispr and OpenAI Wispr, but Parakeet is this really amazing model. And we also have things like Magpie, or these bird names for speech synthesis. So yeah,
I like that. Yeah, it's
pulling
very
that into the
fitting for
model.
speech.
I do
Um,
too.
yeah, and what's great about Parakeet and Canary is I think both of those there's versions that you can run locally too, right?
That's right.
Like, yeah.
That's right.
So, Kari, tell me, if you don't mind, what has it been like working for NVIDIA through this wild transition over the last few years of, growing to essentially the biggest company in the world?
Well, I've been here for a little over 9 years, and it has definitely been a wild ride. You wake up every day super excited because you're working with the best people, the smartest people. Honestly, every morning is like Christmas morning because you wake up like, oh my gosh, yeah, like today? I'm going to attack it. There's so much to do, so much to unwrap, so much to build, put together. And at the same time, Jensen is a really great leader. A lot of people ask about that. He definitely grounds us. Make sure that and the culture is to work hard, to be very transparent, and like I said, work on the hardest problems. And then at the end of the day, deliver the platform so that which people can do their life's work or fulfill their life's work. So that's kind of the sentiment here. That's the culture. Work hard, do good. Yeah.
It's
We
paying
both
off.
regularly talk about, we have a lot of respect for Jensen as well, and just kind of the foresight it took to sort of understand what was coming and be so beautifully positioned, just, right in time to become the cornerstone of modern AI, essentially.
Yeah, he always jokes that what does he say? It's a 30-year overnight success.
I love
Yeah.
that. I
Yeah.
love
Yeah.
that. That's really awesome. So what's your vision? Where do you want Nemotron, especially Nano even, to be in, let's say, 2 years, like, in everyday apps people are using?
Yeah, I think that I like that you said everyday apps people are using because right now, um, again, I alluded to enterprises haven't quite taken generative AI at that last mile.
Uh-huh.
So my vision and my hope is that, when I go to the doctor's office or when I get in my car or when I use whatever everyday app I'm using, it becomes more specialized, becomes more AI infused, and it is based on Nemotron. So I think of even things of like call transcripts from meetings, not just the transcript, but specialized to me in my
Oh,
role at my company and the people that I work with and my acronyms, right? There's a lot of improvement that can be done there. So I think that for me, it's that Nemotron will like be this base of specialization for enterprises in every vertical domain.
yeah, that's so
Like even
cool
think
to
about your
have.
banking app, right? And like I want to be able to talk to my banking app the way and engage with it the way you might engage with ChatGPT or Perplexity. Right? So
Yeah.
I want that capability in my everyday life.
You
And
blew my mind. I've never thought of AI in my banking app before.
I just
So
you just want to talk to it, right?
yeah.
And that's that. And that, we were talking about gym environments and being able to verify things. And if you think about the most success for generative AI right now, it's been coding apps, right? So the way you are able to talk and just type your intent to code, to write lines of code. You don't even have to write lines of code anymore. And the reason why you can do that is because it's so easy to test, right? It's so easy
Yeah.
to verify. It compiles or not. It's a yes or no. Did the code compile? All right, then it's some good code. Did it not? No, right? So it's been really easy. That's why these apps are the first ones out there. They're really useful to developers. But if you think about it, I just want to be able to talk to the rest of my apps and my devices and in my applications in the natural not just talk, engage,
Yeah.
right? And in my own personal way. So if you think about like finance, retail, shopping, like that's definitely going to get there. Healthcare, automotive, like in every industry, energy, like my the my solar panels on my roof. But like, I just should be able to engage with it instead of, wonder. So
Yeah. And for it to
Yeah.
smartly just lower my electric bill while we're at it, and
that's right. Hey, while you're at it,
smartly.
Yeah, that's so cool. Like Corey and I yesterday in a live, we tested the Logan Kilpatrick at Google DeepMind just released like Yap to app is what they're calling it, where you can like talk directly to the app that you're building in AI Studio. And the thing that I was thinking is like I want it to be able to almost like combine a speech model with computer use, where I
that's
can
right.
say like, okay, open my, let's search for, in my bank statements, for example, like search for all of my deposits for this month. Okay, show me that. All right, now let's look at my, how much my expenses were, and like to be able to navigate pages with just chatting,
Yes,
that would be awesome.
exactly. We need to get there, right?
Yeah, yeah.
I
Yeah.
Like
always joke
even
that
just be able to
my,
click a button with talk, I think would be great.
I always joke that my test is, I wanna be able to, when I'm driving the car, holler at my phone to order me a pizza and have it at the door by the time I get home, in 45 minutes or
I'm
something, and
really,
and
yeah,
it know what kind of pizza I want, where I would order from. I
yeah.
want and my credit card and just well, I mean,
Read your
feel
mind. It
iffy
needs
about
to
the
read
credit
your
card,
mind.
but that's what I want.
I wanted like the step right below reading my mind, like it's
Yes,
like
yes,
it
Yeah.
kind of knows what I'm gonna ask, but I still have the agency to decide for myself.
Yes.
exactly. Exactly. So again, specialization, personalization, memory, all these things, systems are being built now. That's what is built out of this infrastructure, so that there's capacity to be able to deliver these types of applications in the way that they need to be built for every enterprise in the future.
That's awesome.
Yeah, that's something people maybe don't the people are missing in the whole like data center debate. They're like, "Oh, are we overspending for this?" It's like, well, if you think about all the things we could do if we have more compute, you're kind of underspending at a certain level.
Yeah, exactly. I just know where we are, and we have so much more to do.
That's awesome.
So I'm excited.
Well, we're sure anxious to keep following it. We've really felt for a while like Nemotron's been slipping under the radar a little bit, and when the opportunity came to be able to have a chat about it, we thought that was a great idea because we've been really impressed.
Yes, well, thank you for having me, because I get excited to talk about Nemotron and the exciting things that we're doing here. So I appreciate it.
Yeah, thanks so much for joining us today as well. Where can people go to learn more and find some good resources on Nemotron?
Well, I think first and foremost, it's all over Hugging Face. So all of our data sets, assets, recipes. You can go to build.nvidia.com and just try it out for yourself. There's an interactive UI that you can use and download the models from there as well. And just at nvidia.com.
If you've liked and enjoyed today's video, please take a moment to like and subscribe. We really appreciate the support. Make sure you check out the Neuron AI newsletter at theneuron.ai as well, and join some 600,000 others who read us every morning. We really appreciate you listening, and that's it for today. Farewell for now, humans.